Good morning, good afternoon, everyone, and welcome to this webinar from Nordic, another webinar in our Nordic Tech webinar series. Thank you for joining. Really happy to see all of you here and people from all around the world. So that's great to see because we are going to talk about worldwide topics today. So the topic of today is 9160, putting the smarts into smart meter. So we talk about smart meter and utility metering. Before we start, let me just quickly go through some practicalities around the webinar today. I'm going to present for around 45 minutes, and then we do Q&A in the end, where I try and answer as many of the relevant questions as possible that you have asked during the webinar. So please ask questions. You should have a question bar on the top right side of the there. They are anonymous, and they are getting into a place where I can see them. So please use that, and please keep them relevant to the topic. And non-relevant questions or questions on roadmap and future stuff will not be prioritized today. There could be more questions. There could be questions not time to answer, or where you don't see a complete answer from me today. Then just use our dev zone and continue there. We have a big tech support team, around 40 people behind dev zone that are ready to help all of you. We also record this webinar, so you can look into it later or browse through some of the details presented and some of the links in the webinar if you want to dive into some more details. For the webinar itself today, I'm going to start to give some overview on smart meters and the relationship to cellular IoT connectivity. Short highlight on the nRF9160, but dive into more specific details on how our nRF9160 solve challenges around smart metering with regard to connectivity, flexibility, integration, edge computing needs, low power consumption, and support, of course, which is crucial for fairly complex application area. So why does a meter have to be smart? So the term smart meter is something that have risen over the latest years and becoming a hot topic all around. And the key reason is the utility infrastructure that is used today is getting more and more complex to manage and maintain. As probably all of you see if you follow a little bit as a private person as well, you know, the mix of energy is getting different than it used to be. Traditional energy sources are moving slowly away. The world is transitioning into green energy, run on renewables like solar and wind, hydrogen as energy carrier, and running on electricity. And this puts big challenges into the infrastructure because especially when you have things like wind and sun, you can have fairly instant on and off in the network of huge amount of energy, and you need to basically be able to utilize that very good towards the end users. And that means that you need to have something on the end user side that can be able to almost real-time report energy consumption and understand the energy consumption on the end user level. And then you have both on the government level and people asking for very efficient network, high transparency with regard to cost, with regard to how things can scale as things are using more and more energy, or as things are on one level getting more efficient, and on the other level new things pop up that need more energy than before. And when we talk about smart meter, we talk about meters that enable the collection and processing of all this metering information, so it can basically help send all the data to monitor and control the utility infrastructure itself, and help improve efficiency in data, energy transmission and distribution networks. And then for sure make more data available, both directly and indirectly, to end user, to help end user make smarter choices on how they use their energy or how they choose to use their mix of energy sources that they have available. In order to really get a smart meter, there's one thing we definitely will talk about and focus on today, and that is connectivity. Able to send its data somewhere and need to be able to get messages from somewhere if it's going to act on something. We talk about wireless, of course, since Nordic is a wireless company, but if you think about meters all around the world, you cannot build wired infrastructure when everything is getting connected in the future. wireless is lower cost, but it's also much more reliable than having wired connectivity. Wired connectivity, you dig into the ground and you break the whole circle, but wireless is getting more robust at basically all wired connectivity and energy transmission lines around the world right now. In addition to connectivity, you need a cloud and an head-end system where all the data is collected and maintained and processed and used and distributed further. And then you need some level of edge computing so that you on edge level can collect, process, take smart decision on node level and use an efficient into the cloud. If you look at the key big utility guys today, they are really focused on the cloud and the end system. They are focused on the outcome. So here is they collect all the data. They use that to manage their utility system, their infrastructure, the data, their customer base, and so forth. So what we're going to talk about and focus on today are the two other big parts. How to get wireless connectivity up and running and how to utilize edge computing to build a smarter solution and better solution. And here we see the challenges starting to arise. Requirements on the connectivity side and vice versa, so they can talk together. So it's very important to understand capabilities of technology and the protocol so that you can build something that fits together with basically a wide range of cloud and head-end systems out there. And they are opting for different solutions. Regionally, you see big differences in what solutions are preferred and adopted. And also within regions, you see different utilities that want to have some flexibility or want to have the ability to utilize different solutions. So all this drives demand for something that is standard-based, something that is interoperable, but also something that is flexible so that it's possible to build solutions that can go global and that you can tune and easily maintain, even though you are putting them into end infrastructure that are fairly different globally in terms of what they required for the meter. So when you look at the key part of this, the meter to the wireless and cloud connectivity, what the key utilities are asking for across the board is something built on standards, of course. We see that there's a fairly good standardization arriving on all different levels today on utility metering, even though there's still some fragments and there's still a portion of all this that is not built to scale globally. Total cost of ownership is, of course, extremely important in this market. Very focused on cost of connectivity infrastructure. These big utility guys, they have energy infrastructure that they need to maintain, which is really expensive. So they don't want to add another big infrastructure that they can that they have to pay on and service basically. And then very simple installation and commissioning, very simple operations, so that you can basically install or even replace all traditional meters with smart meters at high scale, very quickly and very simple. And something that can be up and running 24/7 and it's very robust is very important, of course, so that you don't have to go on site to do maintenance. That's going to be a huge cost burden to these companies. You need to build something that can be maintained remotely so that you have firmware over the air capabilities. Also on the application side, so if you want to add new features, you want to service the application level, you can do that remotely. Security is very, very important. You find a lot of systems today that are built from simpler protocol and simpler standard where you really don't have any security, and that's going to change dramatically over the next years. And these meters are typically, they are installed to run with 15 to 20 years lifespan. So you need to have a solution, even battery operated, that can last for up to 20 years. And the last thing is that these big utilities, they often have multi-vendor approach. So they cannot base their whole infrastructure on basically one meter from one supplier. So they need to have something that are interoperable and built on standards also for that level. So when we talk about wireless connectivity and connectivity standards, cellular IoT is really something that can help scale this in a global sense today. So already, if you look back, especially for the 2G that came in the 90s. That was getting very popular because it had some features that were suitable for machine-time communication and machine-to-machine. But this is getting fairly old as a technology. It's not really low power, so it's not suitable if you want to build small meters with more limited battery sizes that can last for 15 years. It's not based on LTE. So LTE, the standard that many of you refer to as 4G, so it doesn't follow the standard up to include new features and to be future compatible to 4G and now 5G. And this means it's not suitable for new requirements coming in with the low power wide area network. It can't support new features, and it can't basically grow into new applications. And you probably are fairly aware that in regions around the world, 2G is basically now being shut down. US are far along shutting down. AT&T have already shut down their network, and in most of EU, things will be shut down during 2025. So when we talk to all the big network operators and carriers, we are starting to have active discussions with them on how we together can migrate a customer base in 2G over to cellular IoT and LTE, because 2G is not something that will be maintained for many more years in many countries. We got LTE with LTE-M and NB-IoT, and this really offered much more massive machine type communication than was available before. Much more and better low power modes, LTE based, so really a standard that can evolve and take in new requirements as it is needed from the market, and future proven. So when we talk about LTE and especially M1 and NB-IoT being part of what we refer to as commonly as a 4G standard, this continues to live also as the world deploys 5G technologies right now. With 5G, there is more new standards emerging that are also meant and targeted for machine type communications, but none of these standards are built to replace LTE-M1 and NB-IoT. They are higher end standard running on higher frequency, so lower range, and higher bandwidth, but much higher power consumption and higher complexity. So they will never reach the power consumption, the range, and the cost that you can reach with LTE-M1 and NB-IoT. So that's a standard that will continue to live into 5G and further far into the future. There's other standards when we talk about wireless technology landscape as well, and that's especially what we refer to as sub-gigahertz standards. These are standards that can work really well if you have more local and constrained infrastructure, but also here you have a challenge that these are unlicensed and there is some lack of standardization. So to a large degree, you need to build and maintain also the infrastructure around this network, and the infrastructure doesn't have the same capabilities in terms of scalability, future-proofing, security, and uptime guarantee that you will find on cellular IoT. So that's why Nordic as well, we are really focused on narrowband IoT and LTE. It's an open standard that we know is future-proof and can remain for many, many, many more years than today. If you look at these two standards as a glance, I'm not going to give you any hard recommendation on choose M1 or narrowband for this and that application, but kind of give you a short overview so that you can understand a little bit the differences and the key capabilities of these two standards. Go back into Nordic and you will find other webinars that go really in depth on this if you are really interested on understanding more about the difference between M1 and narrowband IoT. But overall, M1 offers higher bandwidth, so the ability to transmit more data. With that, it's simpler to do firmware upgrades and firmware over the air because it's designed to accept and work with much bigger data packets. It has much better mobility, meaning that you can basically have mobile devices that move around from cell to cell without losing data. And there is really good roaming agreements available with M1 today, because a lot of that is piggybacking on existing agreements for that are built for LTE-M and higher category devices. If you look at narrowband IoT, both narrowband 1 that we have today and narrowband 2, which is coming in release 14 and being deployed into devices and network now, it offers lower bandwidth, but the can, at least on paper, offer better coverage because you do have a lower bandwidth carrier that you have. But with limited capability, it offers more limited capabilities on firmware update. Much higher latency than M1, so it offers lower capacity in the network and more limited mobility. And there's one point about mobility which I want you to be aware of, and that is, you think about mobility in LTE, but mobile devices, but you should also consider mobility when you look at the radio conditions for any stationary devices that you put in the market, such as utility metering. Because if you have a utility meter and there is a big truck parking in front of that utility meter every second day and blocking the view to the cell, you basically can have an issue with data transmission if you rely on technology where you don't have mobility. Whereas with M1, for example, you can transmit data and you can then change to a different cell without losing data on the way. So it gives you higher reliability in that sense. That's something to be aware of. Typically what we see today is that electricity meter and more advanced gas and water meter tend to rely on Cat-M1, while more simpler gas and water meters tend to rely on narrowband. But there's no real answer here. It's up to you what you think is best for your application and what the utility company think is best for their application. But when you look beyond the pure connectivity, there is a lot of other things that it's important to think about building smart meters today. Which protocols that you use for data can have impact both on the which type of cloud and systems you can connect to, but also power consumption and data cost, of course. Which protocol you use for device management, these tend to break out and be a little bit different than what is used for data in many cases. Do you want to add edge processing to optimize this data upload? So with edge processing, you can serialize, you can pack, and you can add end-to-end, or you can add object level security and other things on top of these basic protocols that help you optimize your complete application. And as these meters getting more complex, how to achieve low power, how to achieve low latency, if that's important. For example, in gas meters in certain regions of the world where you have to detect leaks, that's becoming really, really important. So these are some of the things we're going to talk a bit more about today. First, a simple glance at the nRF9160. So this is a system in package developed by Nordic, and inside the system in package, there's also a chipset that is developed by Nordic. So Nordic has basically developed every critical component in this solution. The 9160 supports both LTE-M1 and narrowband IoT, meaning from a chipset point of view here, you don't need to make any hard decisions early whether you're going to deploy only an M1 or narrowband network or want to have the option to do both. It also has GPS, and it has a full-blown ARM Cortex M33 microcontroller inside the chipset for the application, so that you can auto host your complete application running inside the system in package and not rely on any external microcontroller. This is fully certified, so it can operate worldwide. We have all the regulatory and a lot of carrier certifications in place, so meaning there is really few limitations on where you can deploy this device today. We are really focused on building a global product, so you can also build global products with nRF9160. Really small, 10 by 16 millimeter. That includes front end, PMIC, passives, crystal, almost everything you need, except basically SIM, antenna, and a few passive and power, of course. So if you look briefly inside the system package, you have the 91 chipset from Nordic with the modem and the application processor, RF front end, power management, and then passives and crystal fitted inside the system in package. We have really focused on building best-in-class front-end and packaging to create a really robust solutions for smart metering. We support 23 dBm max output power, which is the highest allowed in the network today. So that is really something that is ideal for any metering where you need as good coverage as possible. Another thing is that we have very stable and we have a very robust solution that works from -48 to 85 degree, which is higher than most, if not all, other standard modems in the market today. So we can operate with 23 dBm output power and be 3GPP compliant up to 85 degree. That means that electricity meters, for example, placed on the south wall in Midwest US or in South Europe can be really, really hot, and that's where the 9160 is a really good fit, because it has such a great temperature range compared to most other solutions. They also build very advanced, very robust packaging, so we know that this is really fitted into, for example, water and gas applications, where you typically use molding or potting to cover everything, and that is something we have controlled 100% that is okay with all known potting material and molding materials out there. And if you have questions around particular materials, well, you can just contact Nordic and we will help you out to ensure that you choose a material that is fine for the system and package. Then we talked about the importance of be able to build global products. So the 9160 is globally certified with GCF and PTCRB today. We have regulatory, we have certified with all the major standards around the world. We have CE for Europe, FCC, and ICID for North America. Then we have specific country regulatory certifications for other regions around the world, such as China, Korea, Japan, and so forth. So we have completed a lot of that, but we still continue. We are currently working to certify regulatory for Brazil, and we also plan to include other parts of the world next year. And we are very customer driven here also. So if you want to deploy 9160 in parts of the world where we haven't regulatory certified, please get in contact with us. And as a cellular product, at least most of the big carriers demand that you also certify with them. So we have all certified this product with all the major carriers in US and Europe and Asia, and we are continuing to add more every quarter of that to ensure that whenever you want to deploy the 9160 in the world, we can help you to build a product that can really be placed globally. So then let's dive into how the 9160 can help solve some of the challenges around building good cloud connectivity for utility metering. So we're going to talk a bit about more the flexibility, integration, and the edge computing capabilities of the 9160. The power consumption we can offer, and how you can get more support to build your own solution. So if you look at integration first, and the benefit that you have of our system on chip approach, where we have basically integrated both the modem and the application processor into one chipset, we have also built a solution that enables really high degree of flexibility. So let's look at two use cases of meters using the 9160 today. One is in US, running on LTE-M. Using a lot of data, so basically data on demand from the cloud side, running DLMS protocol over MQTT, so fairly data intensive application. This is really low latency application, so it's really important to also be able to control actuator combined with the meter. As you may know, there is regions in the world such as California and Japan where, due to risk of earthquake, for example, it's critical to be able to understand if there's a gas leak and then be able to really very quickly turn off parts of the gas infrastructure. So here there is meters that is built to not only send data, but also quickly receive data from other meters or from the cloud to instruct it to do some additional measurements or shut down if there is a risk that there is a leak in the region or nearby. It's using HTTP for application firmware over the air, and using lightweight machine-to-machine, because with most of the major carrier in the US, you need carrier device management. So you have requirements there that you need to fulfill also on the end product level. Still a very low power product running from battery that targeted to be in the market for 15 to 20 years on a single battery. Then we have another meter for utility in Europe. This is running Narrowband IoT. Less data intensive, pushing data over UDP, so simple UDP. That's very, very basic. And then using also lightweight machine-to-machine for device management. Also application that need to be very low power, which operate from 15 to 20 years on a single battery. And here you see that there is great diversity in what type of features you need to put into the utility meter, also when it comes to the connectivity part and the edge computing part, in order to build a solution that can be used by different utilities around the world. We see generally that there is a trend to go to more complex, should we say complex protocols? We can call them complex if you then look back and look what's traditionally used in utility metering. This has to do with more complex infrastructure being built. It also has to do with the ability to talk to the devices back from the cloud, do firmware updates, and serialize, pack, and build end-to-end security or object-level security into the application. We also see trends that you need to have multiple socket connections to different clouds, because there could be different clouds for data and device management, for example, particularly when there is network carriers that also have requirement for device management that you need to take into account. And all this is something that we support and are doing and can do on the 9160 today. If you then go and look at some further observations that we talk about here, and what we see is that typically we see LTE-M when you need high speed and high capacity, and when you have, should we say, even for stationary devices, need to take into account that there could be network environment changes due to, as I said, could be trucks, could be someone dumping a lot of gravel on top of a meter that is subground and things like that. So you need to take care into that. When you have high capacity, we see that power consumption is less correlated with payload size. So typically with LTE-M, you will see that you pay a little bit more in power consumption if you're sending very limited amount of data. But if you're starting to send bigger packets, so let's say a few kilobytes of data every time, LTE-M become very beneficial because it's much more efficient when you have higher payload size. While with Narrowband IoT on the other side, energy consumption tends to be fairly linear with the payload size that you have, because the protocols are simpler. But you also here reach into a into a point, where your payload size increase above a certain point, you can be more beneficial to utilize LTE-M1 because it's more efficient. LTE-M Narrowband IoT is also built to be have less bandwidth and lower capacity. So this is something we don't recommend if you have meters that need to upload data fairly frequently. And this also comes back to that with Narrowband IoT, because there is limited capacity in the network, a lot of carriers put actually limitations on how many connections or how much data you can send over a certain period of time in Narrowband IoT. That's something you need to think about if you plan to deploy or plan to work with a utility that need to deploy meters in regions where you need to have or are asked to put Narrowband IoT in place. Make sure you understand what limitations, if any, that the carrier have in that region. And then if you look at the protocols running on top, on LTE-M, you typically run MQTT or TCP. So as I said, very good if you have larger data packets. They're very popular, very well supported today. So if you any cloud or any head-end system you want to connect to, they typically support MQTT. Co-op and also lightweight machine-to-machine building on top of co-op has less overhead than MQTT, and is really helping to build much more reliable UDP connections than you do with pure UDP. That is the suggested standard for Narrowband IoT. But it's not that popular yet, but we definitely see that that's growing in popularity, because there is in utility metering and but also in other applications cases where you don't need to send a lot of data, and then it can be really beneficial to use a more lean protocol than MQTT. We did a webinar back in Q4 called Cloud Connectivity and Protocols for IoT. So if you look at that webinar, we go into a lot more depth on these topics and show you some real life examples on where is the, should we say, threshold between, for example, running MQTT and CoAP, depending on your payload side. So look at that if you're interested to understand more about these topics. So going then into adding 9160 to a utility meter. Keep in mind that with the nRF9160, you add both the connectivity that you need, but you also add a fully open application processor with a very simple development environment so that you can also build your application here. Let's directly talk to the metrology part of your application. So there's two ways of using the 9160. So I'm going to first talk about this system on chip approach, where your application is running on the application processor in the 9160. So here you add edge computing capabilities, and you add a lot of flexibility in comes to protocol stack. If you want to support different protocols, or you want to deploy different version of your product with different protocols, but built with the same hardware. So the application processor on the 9160 is running 64 megahertz ARM Cortex processor. It has dedicated memory, 1 megabyte for the application, dedicated peripherals and system peripherals for the applications. So this is fully dedicated to you as a developer to use. You don't need to share any of this with the modem. The modem resides in separate domain, running its own stack, and has its own memory and CPUs for running those stacks. So they are completely separate, and that gives you a lot of flexibility without having to think about how to partition your system between the modem and the application processor, even if it's on the same SoC. So if you look at the 9160 more on a software stack level, to give you a little better understanding of how this looks, you basically have the modem with M1, Narrowband IoT, Narrowband IoT 2 coming now, and GPS. On top of that, we have a socket interface to the modem, where you directly run on protocol level can run data. So this doesn't just have a, should we say, a standard 80 command set that you are used to from a traditional modem. You also have a much more efficient way of communicating to the modem with socket, especially if you're going to send a lot of data. On top of that, we have a lot of protocols available. So all of these are seamlessly integrated and designed together with the modem. Whether you want to run CoAP, lightweight machine-to-machine, MQTT, device firmware update, TLS, we have real-time operating system here, and all the drivers, of course, that you need to build something. So on top of this, you can build your connectivity part, but you can also build your complete applications, meaning that you don't need to write any drivers or have any 80 command interface to the modem. That's all been taken care of in the lower layers here. You have a lot of flexibility, because here you can basically take in and out whatever protocol and feature that you need to build your product. So typically you build in more of this if you're building very global products, but you can build in less of this if you build more regional products. Everything you see here is available inside our software development kit that we call the nRF Connect SDK. So the nRF Connect SDK, that's a fully open source SDK that you can use to build your complete application with all the protocols that I mentioned, Zephyr operating system, all the drivers to the chipset, and examples on complete applications so that you have a simple way to start your development. The other thing which is great about the nRF Connect SDK is that we now have the same SDK whether you're going to do cellular development, Bluetooth Low Energy, Zigbee, Thread, or other wireless technologies that Nordic support. So this is the same SDK and the same tool chain, both for nRF9160, but also for our new nRF53 and nRF52 short-range wireless devices. So in summary, if you want to use the 9160 and use what we call system on chip approach and write your complete application here, We basically support all the protocols that you would need to run for a typical utility metering application. We have a fully open SDK used by basically thousands of different customers, so really mature, really a lot of examples and really a lot of contributions. And then we support both LTE-M and narrowband IoT, so that you can build a solution that can fit any requirement that you have in your end environment. So here is two examples actually of really nice and innovative smart metering product built around the nRF9160. So Lobaro have built a solution where they not only run their application and their LTE stack on the nRF9160, but they also run the stack for MBus and LoRaWAN inside the nRF9160. So this can basically host multiple stacks. So they can also use the 9160 in gateway and in application that have just local shorter range or other networks such as LoRa, and then using 9160 as a gateway to basically process all the data and send that up to the cloud on behalf of all the LoRa nodes. We also have a solution by Gurux where they have basically taken a traditional meter with DLMS connectivity, wired connectivity, connected that to the nRF9160 on our development kit, and then creating an MQTT bridge. So you can basically then transmit data over LTE-M with MQTT straight into the cloud and into the client application running and fetching data from the cloud. So there's a lot of flexibility that on how you can build products not only running in your application on 9160, but also use the 9160 to bridge from other traditional protocols or non-IP protocols that you also have in your infrastructure that you need to collect data from. In addition to running your own application on the 9160, we also have the ability to use the 9160 as a traditional serial LTE modem. And there could be several reasons for that. Could be time to market. You don't have time to basically move your host into the 9160. Or maybe you have a host so that you need to have a really, really powerful host because you have a lot of memory and a lot of heavy protocols on the side that you need to support, and you can't fit everything inside the 9160. So turning the 9160 into a modem, we basically then have a serial LTE modem application running inside the application core so that you can use 80 commands, traditional 80 commands from the host and communicate to the 9160. But all of this is also open source. So we provide this as an application, but we can also provide all the source code through our SDK so you can do any changes to that as you want. So this can be a way to start with the 9160 if you want to have very simple migration. So if you look at all their cellular modules, typically 2G, this is the high-level infrastructure that you're working with. You have a modem, you have 80 commands, and you have then a host running all the stacks you need, all the protocols on application side and the metrology. And you can basically do the same with the 9160 if you want to get started very quickly. Then you put the serial LTE modem application into the application processor and start using 80 commands as before to use the 9160 and transition your application from 2G to future-proof and low-power LTE-M and narrowband IoT. Moving on, it's then possible to start migrating some of the code to offload the host or to go to a smaller host or everything to basically get rid of the host altogether. Because this serial LTE application is open source, it's possible for you to build other functionality into the 9160. This application uses roughly 10% of the memory, so there is still plenty of memory left for you to offload with host with sensoring functions or running protocols in the 9160 and not in the host and so forth. If you want to gradually migrate your device on to simplify your bill of material, lower your cost, and then build a more compact solution. The other thing which is really important in utility metering is power consumption. Gas and water meters are battery powered, and you need to build something that can last for 15 to 20 years many times, and you need to build something that is predictable for the market you want to deploy in. So starting off with a little challenge on that. especially if you're used to working with the short-range wireless technology such as BLE, Zigbee, and Thread, you do have a fairly predictable setup in terms of power consumption. When you're moving to cellular, you are in the situation that the network is in control of a lot of parameters. So this example is showing basically average power consumption if you're running 82-second eDRX cycle with the 9160 in one network in the USA, but in two different locations, Boston and California. So this is exact the same application, same product, same network, and so forth. And you should expect that you get exactly the same average power consumption here, but in fact you don't. You get 25 microamp in one location and 32 microamp in a different location. And this is basically because even though there is one, you're connected to the same carrier here, there's different configuration. It could be different infrastructure, different equipment that have slightly different features in a different network. So the power consumption that you can achieve also depends on network settings, right? So looking at these numbers, 25 and 32 microamp is still super low eDRX power consumptions, right? But you also see that 32 microamp is still 20 to 30% higher. So if you look at the average power consumption for battery life for these two applications, you basically need to take into account that there could be some differences in different network, and you need to have some headroom based on that. Network settings can be a little bit different in different places. This is something that we focus a lot on so that we can help you out, because the complexity level here is not something we expect you to fully understand and take care of. So we are working, and we already have different tools that can help you out to do this. We have optimized all our hardware and software, so we really have the lowest power consumption in the market today on the 9160. That means that our 9160 will always be optimized depending on which network setting is available. The modem, for example, will not only go to PSM and eDRX sleep. The modem will go to sleep even during transition, during CRX and other modes, simply because it knows exactly how the network operates and we have optimized everything ground up for that. When you put everything together, you have a really efficient interface between the modem and application. That will also help you to really optimize your application and really understand more of what's going on the modem and the network side to help take smart decisions, whether you should send data now, for example, or whether you should wait, because the network environment is bad. So you can expect a lot of repetitions and highest possible output power. We also do a lot of testing, and we can help you to do different testing to help you understand how LTE works and help you test very specific cases that you need to have full control of. So the nRF9160 is a really ultra low power solution. We have less than 3 microamp in PSM current, fully retained, so that you can wake up in microseconds, and you don't have to reboot or reconfigure any stack or get any network parameters from the network. Everything is retained in the device. And our eDRX average current in the optimal case is 18 microamp with 82 second eDRX. But as you saw on the previous slides, 18 microamp, it also depends on network settings, right? So we don't control that 100%. So we have developed a couple of really nice tools to help you understand power consumption for LTE when building your application. We have an online power profiler, which basically is an online tool where you can go in and you can plug in different network parameters to basically test, and also application parameters, basically test what your max and average power consumption would look like, to have a basic starting point for calculating battery life. Also now here we have actually some real network parameters that you can select from, so you can see yourself what is the difference in different networks for your application if you plan to deploy a global product, for example. We have also recently released the Power Profiler Kit 2. So this is a really advanced but low-cost power analyzer that works directly with the 9160 development kit. In addition, we have now built fully customized application examples for the 9160 that are complete examples showing both device but also up to cloud connectivity, so that you can download a simple application, and you can download an application and export your settings from this online power profiler to basically test the exact same configuration on a real device to see what it means real life. And here you have a really nice software tools and front end so that you can basically real time see a full profile of power consumption as the 9160 is running. And that means that you start with our basic example. When you build more functionality in, you can continue to use to monitor your max and average power consumption and start to see when something becomes too heavy or when you have some issue or question you don't understand. Then you can come back to Nordic and we can help you to figure out that. We can offer you a lot of support, mainly because we have full ownership of the solution. As I mentioned, we have designed both the chipset and the module. So if you have any questions to the 9160, either it's the chipset, the module, the application firmware, or the modem firmware, we can answer all of that. So basically a single place you can go to get help. We also have online technical support center called DevZone. Here we have really almost 40 people working behind this portal, helping everyone, regardless of how big or how small you are, with technical support. And we have a forum with more than 70,000 users that also contribute a lot. And as I mentioned earlier, our SDK is open source, but also all our documentation is open. So you don't have to sign any NDA with Nordic. You can go to our website and you can download the latest product specification 9160 with all the power characteristics and all the details. You can download white papers on help you on hardware design and software design and all the documentation we have. We host all our open source SDK firmware on GitHub. So you can basically go here and download everything through GitHub if you want to. So once you get going, you might have more questions or you want to talk to us first before you go. If you go to our webpage, you can find basically a form where you can get directly in touch with our regional sales management team. We also have a dedicated business development manager for utility metering, Lorenzo. So feel free to contact him also if you have any questions on that, and he will help you out to get more documentation, get you started, or get your input if you need any particular things from Nordic to help you get going.